Hello everybody, Charles here from Surefire Engineering. So today we're going to do another video, but I thought for the opening shot here, practice my hand phonography skills, I'd give you guys a shot of the beautiful September scenery here in Honam, South Korea. Now, let me pan over here a little bit. Okay, so let me go back here. That mountain right there in the background, this one right here, is called Keijo-san, and it's about 860 meters high, but it's absolutely beautiful. It's actually in a national park here. All right, so let's get to the video. Today we're gonna have another video on devices that can switch the current going to your heating elements. Now basically there are three main methods of doing this. One is using a mechanical relay, the other is using a solid-state relay, and the third and preferred method by Surefire Engineering is to use an SCR. Now, first we'll talk about these two devices, the mechanical relay and the solid-state relay. When you look at these, it's obvious the first thing that they have in common is that they both switch a high current using a low current. Now I'll refer to the switching current as the pilot current and the high current as the load current. Another thing these two devices have in common, which isn't so obvious until you start analyzing their failure mode, is that when they fail, they can both fail in the on position. So what that means is that if this mechanical relay fails, it can fail in the closed or in the on position, resulting in continuous conduction of current to your heating elements. The same thing with the solid state relay. Now, this can be very dangerous, of course, especially if you're running a pottery kiln or a knife making furnace, assaying furnace, whatever type of thermal processing machine you have. If they fail in the on position, that means that device is going to continuously heat up until it fails or catches fire. And this is going to wreck what's ever inside. It can wreck the kiln or furnace itself. And in the worst case, it can catch your house on fire. That's why at Surefire Engineering, we do not use these devices in any of our kilns or in our retrofits. What we use is called an SCR. Now, an SCR is a very special device. It can switch the current on and off. It can also vary the voltage, which is a beautiful option. I mean, it's pretty awesome. A while ago, these things were too expensive to be able to just, provide to the end consumer. And they were also very large, but with the improvements of microcircuitry and manufacturing technology, the cost of these SCRs has come down considerably. Now this one here is made especially for us, for Surefire Engineering, by this particular manufacturer, and what we ask them to do is to remove all the bells and whistles. So no RS-45 communication ability, no alarm switching, no extra relays or anything like that. Just the basic phase angle control ability. And I'll get to the phase angle control or phase angle firing here in a moment. But because they stripped this thing down to the bare bones, we're able to get these at a very cost-effective price, and we're able to pass the savings on to you. We're also able, therefore, to pass the safety aspect of these SCRs on to you, because when an SCR fails, it will only remain briefly in the on or in the closed or conducting mode. As soon as it crosses the zero line, the zero voltage line, it turns itself off, and it would have to be re-triggered to come back on, and I'll get to that in a second. The other thing that these two devices have in common is when they switch on the full mains current or full mains voltage. That means they're dumping whatever your outlet is giving them into the heaters. And this sometimes becomes apparent whenever you turn on a cold kiln or cold furnace and the heating elements switch on. You can see the lights dim just slightly. That's because it's drawing, major current from your household network. This device, on the other hand, has the ability to vary the voltage, hence limit the amount of current going to the device, and it also has a ramp-up feature, which is programmable. So in other words, you can tell it to, okay, when it comes on, do not use full mains voltage or do not use full power. Ramp up over, I don't know, 2 minutes to full power. And again, this is possible because of phase angle firing. Now, phase angle firing sometimes confuses a lot of people, but it's actually very simple. And let me get these out of the way here, and I'll go to my diagram. And this is exactly how a basic SCR works. So let me move back here a little bit in the shot. Okay, so basically what we have here is a sinusoidal wave that varies in amplitude over time. Time is this way, and this is the amplitude. So up here we would have 220 volts peak, and then we have the 0 volt, of course, where it reverses polarity and then goes negative. From this point to this point would be a whole 360-degree cycle. This would represent 1 hertz. So if you have a 60 hertz system, this thing cycles 60 times per second. Okay, so now how does the SCR work? The SCR works like this. The semiconductor arrangement inside requires a small pulse to be able to cause it to conduct or to trigger it on. Keeping this in mind, what happens is as the voltage increases over time in the cycle, and then it reaches its peak here at 90 degrees, so that would be 220 volts, right? And then it decreases again over time, heading towards the 0 volt line where it reverses polarity again. And then it increases again on the negative side of things. The SCR, what it does is that as it decreases, and let's say it reaches this angle here of 135 degrees, which is the angle between this line and this line here. This would be 135 degrees. 135 degrees represents 110 volts. So it would trigger or send its pulse to conduct to its semiconductor right here. So that means that it would turn on at this point in time on the sine wave, allowing 110 volts peak to go through. It would remain on until it reaches the 0 volt or 180 degrees, where it naturally turns itself off. It would remain off throughout this entire cycle, throughout the negative cycle, until it reaches 270 degrees, goes past 270 degrees, and reaches 315 degrees, which again corresponds to 110 volts negative, and then it would come on. This is basically phase angle firing, and what this allows you to do is it allows you to trigger the conducting point, or the conducting event, I guess you could say, at any point along this curve. So let's say if we wanted to trigger it at, we'll come back here, let's say we wanted to trigger it at 170 degrees, then you could trig that out whatever voltage that would be that it would allow through. The safety aspect of these SCRs is that, like I said, whenever they cross this 0 line, or whenever they cross and the polarity of the voltage reverses, they automatically turn themselves off. After that, they remain off until they're triggered again. So if the device were to fail, let's say at 135 degrees, you would get this last remnant of voltage coming through, and then it would turn off, and it would remain off. And this is a big deal. I mean, seriously, people, because most furnaces that are commercially available to consumers do not have an overtemperature loop. An overtemperature loop is a secondary temperature control loop inside the furnace that is independent of its control, that monitors the temperature, and once it surpasses a certain set point in that overtemperature loop, it kills the power to the furnace. I believe in the US, OSHA requires all industrial furnaces to have this. I do not know why they don't do it for consumers' furnaces. It'd probably save a lot of people a lot of headache. Using an SCRs helps you kind of mitigate some of the risks of not having an overtemperature loop. We had a customer call us up, and they wanted to order one of our kiln retrofit kits, upgrade kits, where we basically provide them a means to retrofit their kiln with an SCR, a new temperature controller, a touchscreen control, and a module that allows you to monitor the kiln and control the kiln over the internet through a smartphone. You can also do it locally via a Wi-Fi connection. Now, they called us up and they said, yeah, you know, we're turning on our kiln. It was a pottery kiln, 25 kilowatts. And when we turn it on, it comes on and it just stays on. And fortunately, they turned it on and the potter hung around long enough to realize that this thing, you know, reached 1290 degrees Celsius. And of course, it wrecked everything inside. And they called us up, you know, wanting to retrofit everything. And we went out there and checked it out. And of course, we found one of their relays had failed in the on position. Anyway, so where are we at? Oh yeah, back to the phase angle firing. So basically, like I said, over time, the voltage varies in the sine wave. It reaches a certain point, a certain angle, and the SCR is able to turn it on at that angle, allowing a certain amount of voltage through. Now, when I say 110 volts, of course, that is the peak voltage. To figure out the true RMS voltage, you would have to figure out this area here under the curve, and then you would get your the RMS voltage, or the root mean square. Not the area, but you would have to take... anyway, that's a different video. I'm not going to get into that. So in the end, what you're going to wind up with is using phase angle firing. If you looked at it on a scope and we're triggering it at 135 degrees, which would be 110 volts, right, which would be half of the mains voltage here, which is 220, you would get a sawtooth wave that looks like this. Some of the fancier SCRs can actually trigger the event, or the conduction event, prior to this 90-degree mark. So then basically you would have, of course, the pin stops working at the most inconvenient time as usual, but then you would have this entire area conducting, and it allows you to do different things. You can also pulse fire it to where it allows a certain amount of full cycle pulses to go through within a second, or you can configure it to only allow half cycle positive pulses through or half cycle negative pulses through. They're very, very, what's the word I'm looking for? They're very convenient devices that allows a very broad range of application. So anyway, that's pretty much it for our video today. I hope you enjoyed it. We're going to try to keep the videos coming over time, to keep you guys up to date on what we're up to. Oh yeah, and one more thing. This video was just basically on applications and stuff. If you guys want to learn the theory behind this, there's a really awesome, excellent channel, which I believe is probably the most underrated channel on YouTube about electronics, because Chris goes into, oh yeah, the channel is called Chris's Workbench. I'll leave a link in the description below. But he goes into the application, he explains the theory, and he shows you the formulas and equations that you need. Like I said, really underrated channels, awesome channel. Please check it out if you want to learn more about industrial electronics and control systems. All right, that's pretty much it for our video today. Please like and subscribe, and we'll see you in the next video. Thanks. Bye. Okay, one more thing. I looked at this video, and when I make these videos, they're not scripted. They're just kind of shot from the hip. So I just like show and I talk. And I noticed that I made a little tiny mistake towards the end of the video, and my OCD will not let it go. So basically what I said is that the waveform would look like this if we triggered at 135 degrees. Actually, that's not correct. If we triggered at 135 degrees, it would look like this. So this waveform, the sawtooth waveform, you would get if you triggered at 135 degrees and you triggered at 315 degrees, which both corresponds to a positive 110 volts and a negative 110 volts right here. So to correct myself, the sawtooth waveform you would see on the scope is if the SCR triggered at 135 degrees and then again at 315 degrees. So I just wanted to get that straight so I can sleep at night.